Clapton Ley, a picturesque village a few hundred metres from the Devonshire coast. Largely untouched, it sits surrounded by vast swathes of empty land and an average residence age of 200. As disturbance is minimal, an ancient forest sits closely by, ever watching of its residents. Field voles, bank voles, laughing species, and mustelids to name but a few. The range of prey and predator species we began to think of their relationships and therefore behaviours towards each other. Small mammals are known to move along from feeding locations after weighing up the economics of their costs over their benefits in a feeding patch. This is known as their giving up density. This led us to start thinking about the GUDs around the Slapton Field Centre area. We consulted literature and found a fair few ideas bouncing around that incited our interest. Our hypothesis, right here, was derived from a few sources. Pusianus, this guy, found that large predator scents do not affect prey feeding, but that strong cover had more of an influence on the GUD. This other guy found that cover positively correlates with lower perceived predation risk, less cost, more benefit, and therefore lower GUD. And these two both found that small mammals and mice respectively preferred forage under higher cover.
Weighed out 100 grams of peanuts and then covered them with sand. We used 15 different trays, and we also prepared tubes with double-sided sticky tape in, as well as 3 white tiles. We made our way to the field and chose 3 levels of cover. Firstly, in light cover, we measured out a 50-metre transect with 1 tray every 10 metres. We placed 2 sticky tubes as well as 1 tile at each level of coverage. The second site was partially covered, where we did our second transect. We set up a camera trap next to one of the trays to record any visitors. Finally, the third site was heavily covered with thick bracken and brambles.
The following day, we sieved out the sand and measured the weight difference in nuts. We found that 1 tray had fallen over and was empty. We replaced any lost nuts back to 100 grams and recovered with sand. We then looked at the tiles with the UV torch. To compensate for water weight, we weighed a handful of nuts, put them in a mug with water, and let them saturate for 2 hours, then weighed them again and calculated the percentage increase.
We carried out a cross-cow Wallace on the overnight cover types as we found our data was not normally distributed. We then found there was no significant difference between the groups with a p-value of 0.38. We had to omit one of the data points as there was no sand or nuts in it, so we suspected that sheep stood on it and kicked it around. We carried out an independent samples t-test on the medium cover and full cover as 3 of the 5 samples had been disturbed by sheep in the open cover, so we couldn't do a statistical analysis on the open cover. Sheep also disturbed 2 of the medium cover samples, thus giving us only 3 usable data points. We found there was no significance between medium and full cover with a p-value of 0.197.
Oh, didn't see that. A paper by Wheeler and Hick found that foraging costs may be higher in dense vegetation as a result of predation from larger mammals hiding in the brush. Otters and badgers are quite common at Slapton Ley. The nuts were more easily accessible at the open habitat, which may have caused increased consumption of nuts. There was a thick wall of vegetation on all sides, but 1 in the full cover habitat. It may be easier for small mammals to build burrows in the open fields due to less roots and thick vegetation impeding their digging, causing populations to be higher in the open habitats, resulting in more feeding occurring there. In the future, we could count the nuts as well as weighing them, to eliminate the effect of weight gained by water, and also leave the trays out for a longer period of time, perhaps a 24-hour period. We would also not conduct the experiment in a field containing sheep, as they mercilessly attacked our trays, greatly reducing our sample size.